All right, 2.7. Today we're going to get into parallel lines and transversals. So we're going to identify what those things are, and then we're going to identify some relationships that occur between them. So a couple of questions just to think about here before we get started. One is, we've heard the term parallel before. How can you tell when two lines are parallel? So be thinking about that. How can you tell when two lines are parallel? And then how can you tell when two lines are perpendicular? Remember that a perpendicular line is a line that, well, I should say set of lines, is lines that meet at a 90-degree angle, right? So how can you tell when that happens? Um, and then thirdly, where do parallel and perpendicular lines show up in the real world? All right, so those are some essential questions, some things to think about as we're going into this. And let's get started. So first of all, let's talk about what a transversal is. A transversal is a line that intersects two or more coplanar lines at two different points. Okay, so if you have two lines that are on the same plane or like the same piece of paper, and then there's a line that goes through those two lines, the line that goes through the two lines is called the transversal. So in this particular picture, the transversal here is this guy, all right, line T. And the reason that's the transversal is because it goes through the other two lines, right? So the first part of this lesson is, can you identify these things? T is the transversal, and the reason is it goes through the other two lines. Now, for transversal, there's always relationships. For any transversal, there's these set of relationships. Okay, so if you're making sense of this chart, and this chart's on page 169 in the current textbook, but section 2.7 should be right there in the beginning. So this chart shows you a bunch of these relationships, and it uses this picture right here to do that. Okay, so it says here that four interior angles lie in the region between lines Q and R. Okay, so if you have a transversal that cuts through any two sets of lines, like a pair of lines, right? So if you have a transversal that cuts through here, what it creates is it creates four interior angles. Those are called interior, okay? So that's interior. Next, it says we also have four exterior angles, right? So that would be the blue dots here. Okay, so we have four interior angles, four exterior angles. Now that we know that, we can say some things about these things. So one is what we call consecutive interior angles. These are interior angles that lie on the same side of the transversal. So notice here, and I can do this in another color, if you look at their example, 4 and 5 are here. They're on the inside, and they're consecutive. They're on the same side of the transversal line. So then on the other side of the transversal line, you have the other two, 3 and 6, right? Then, so this is just identifying these things, then we're going to talk about the relationships between them. Then, for the next one here, we have alternate interior angles. Alternate interior angles, and maybe I shouldn't use green here. Alternate interior angles are non-adjacent interior angles that lie on opposite sides of the transversal. Okay, so 3 and 5. So here, this guy and this guy. Right, those would be considered alternate. And then hopefully you can see that there's another set of alternate there. I'll do it in another color. 4 and 6 are alternate interior angles. Okay, so that's alternate interior. Then we have alternate exterior. Alternate exterior are non-adjacent exterior angles that lie on opposite sides of the transversal. So these are on the outside. The exterior tells you it's on the outside of the two lines, right? So for this one here, we would have 2 and 8. We would also have 1 and 7. Okay, those are alternate exterior angles. And then finally, we have corresponding angles. Corresponding angles lie on the same side of the transversal and on the same side of the line P and Q. These are called corresponding. So let's do a couple of examples of those. So first one they give you is 1 and 5. Okay, so notice they're on the same side of the transversal, and on the same side of the lines. So notice here that 1 is on top of line Q, 5 is on top of line R, right? So there's a lot of these in the picture. Okay, so 2 and 6 would be another one. 4 and 8 would be a pair. 3 and 7 would be a pair. Hopefully you can see those there. All right, so let's look at an example here and try to identify some things. It says classify the relationship as alternate interior, alternate exterior, corresponding, or consecutive. And again, we're just going to use these guys, right? So 3 and 7. If we're looking at 3 and 7, 3 and 7, notice that the transversal is the line that connects the two lines. Okay, those are both on the inside, but they're on opposite sides of the transversal. So we would call that alternate interior. Okay, so 1A would be alternate interior. For 1B, we have 5 and 7. Okay, so let's look at that. 5 and 7. 5 is here, 7 is here. These are on the same side of the transversal. They're not both inside, so one's inside, one's outside. Okay, so it can't be alternate exterior or interior because we have a mix, right? So whenever you have a mix, you have it boiled down to corresponding, right? Corresponding, or it could be consecutive, but consecutive happens both on the inside, right? So so if it's one on the inside, one on the outside, you're down to just one possibility, and that is corresponding. Okay, so now let's look at 4 and 8. 4 and 8. So these are 4s on the outside of these lines, opposite sides of the transversal on the outside. So this is going to be alternate exterior. And then the final one, 2 and 3. 2 and 3, they're both on the same side of the transversal. They're both on the inside. So since they're on the same side, they can't be alternate, right? Alternate means opposite. So this would have to be consecutive. These are consecutive, one right after another. It makes sense. There's nothing in between them. They're consecutive. Okay, so the first part of this assignment is just identifying those relationships. Now, let's look at parallel lines. Parallel lines are coplanar lines that never intersect. Okay, so if you're graphing parallel lines, if they never intersect, they better have the exact same slope, right? So parallel lines, if you remember from Algebra 1, they have the exact same slope. Slope will never change. This is a parallel line. These will never intersect. Skew lines are also lines that do not intersect. Here's the key difference here. With parallel lines, they're on the same plane. Okay, they're coplanar. They're on the same piece of paper. With skew lines, you can think about these being on separate sheets of paper. Okay, so for a skew line, you have one going off in one plane, and then you have another line like on another plane going another direction that they'll just never cross, right? It's hard to show it on in two dimensions here, but you can imagine it being on two separate sheets of paper, right? So they'll never cross just because they'll miss each other. Those are called skew lines. And then we have parallel planes. These are planes like sheets of paper that will never intersect, right? They'll have the same exact slopes of the plane in space. And then we have some postulates built on this. So the corresponding angles postulate. So if two parallel lines are cut by a transversal. So notice how they're showing parallel here, you guys. That's important as well. Parallel lines are shown with these little arrows here. These little red arrows show that those things are parallel. Okay, so in your textbook, if you want to know if two things are parallel, it's got to tell you. That's how it tells you. Okay, so these two parallel lines are cut by a transversal. Okay, the corresponding angle postulate says that each pair of corresponding angles, which they've done in different colors, which is nice, so like 1 and 3, 7 and 5, 2 and 4, 8 and 6, those pairs, okay, those have to be congruent. Okay, and you can even see it here. You can look at it here, and you can see that is the case, right? So 1 and 3, if there's a line that cuts through those things and those things are parallel, doesn't matter the slope of that line, it's going to create two congruent angles there. And in fact, it creates 4 sets of congruent angles. So we have 1 and 3, 2 and 4, 8 and 6, and then the other one would be angle 7 and angle 5. Okay, that's a corresponding angle postulate. So let's use that example. Here's another example here. I don't know if it's example 1, it's probably example 2. In the figure, suppose that angle 8 here. So angle 8 is 105 degrees. Find the measure of each angle and tell which postulate you used. Okay, so well, these are parallel lines. Okay, so if that is 105 degrees, then I know by the corresponding angle postulate that this is 105 degrees. Okay, now another thing that I can figure out here, so this is 105 degrees, they want to know angle 2. Okay, well this is a linear, notice that this is a linear pair, right? Here, 1 and 2 make up that line, and we know that a line is equal to 180 degrees. So I could say that angle 2 is equal to 180 degrees minus this other angle, right? Because it together 1 and 2 make up 180. So if I do that here, I get 75 degrees. Okay, 75 degrees. And let's look at angle 3. Angle 3 is also a linear pair with angle 2, so you could use linear pair as well. The linear pair, definition of a linear pair here. And we could say that 3 is also 105 degrees because they're on this line, right? So together they have to make 180 degrees. The other thing that we've kind of talked about is this idea of vertical angles. Last time we talked about vertical angles. So we know that 1 and 3 are vertical angles. We know that these are vertical angles, right? These guys are vertical angles. So you can also use the vertical angles postulate to solve for angle 3. All right, so here we go, guys. The last thing, and I know this video is a little bit long, but here's the important parallel line angle theorems. Make sure you get these in your notes. Okay, so if you have parallel lines, this is important that we are only talking about here parallel lines. So the whole lesson today is not on just parallel lines, but there is a big section on parallels. So if we're talking about parallel lines, these relationships hold. So make sure you identify whether or not they're parallel before you try to do this. So 3.1 says, if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Okay, so in this case, the alternate interior angles would be 1 and 3. That would be one pair, and the other one would be 2 and 4. Those guys have to be congruent if they're parallel lines, which should make sense because they have the exact same slope, right, cut by a transversal. And then 3.2, consecutive interior angle theorem. If two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Okay, so here we're talking about these guys, 1 and 2. If we add those together, they have to equal 180 degrees. And the reason for that is if you look at 3 and 4 there, or even if you look at this missing piece here, we know that as a linear pair, they would have to equal 180 degrees, and we know that those two things are going to be the alternate, the alternate here, the yellow and yellow, would have to equal 180 degrees. So therefore, by that, we know that consecutive interior angles have to equal 180 degrees. Okay. 3.3 states alternate exterior angle theorem. It states that if two parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. Okay, so this guy and this guy have to be congruent. Okay, and then 5 and 7 also have to be congruent. So any alternate exterior angle, if those are parallel, have to be congruent. So let's look at this. So example 3 says the measure of angle 1 here is 100 degrees. Okay, so that's 100 degrees. It says find the measure of angle 4. Okay, so do we have a relationship between 1 and 4? That's the question, right? So 1 and 4 don't necessarily have a relationship. We could say that these roads are parallel, so we can assume that these roads are parallel. If those two things are parallel, what I do know is that if this is 100 degrees, okay, and this line's cutting into this straight line here, then I know that this has to be 80 degrees. Right? Because together they have to make up the straight line, which is 180. Once I know that that is 80 degrees, I have a relationship between that and this, right? Those are considered corresponding angles, and the corresponding angles postulate says that those two things have to be congruent. So once I know that that's 80, I can say that angle 4 is also 80. Okay, so you got to use a little bit of train of logic there to figure that out. Let's look at one more here, and then I'm going to let you guys go on your own. So for the measure of angle 3, it says if 3 is 70, find 4. So let me switch colors here. So 3 is 70 up here. Find the measure of angle 4 down here. Well, that has a relationship right now. Those are alternate exterior angles, right? And here, our alternate exterior angles theorem says that if two parallel lines are cut by a transversal, then those things have to be congruent. So if 3 is equal to 70, then I know 4 is also equal to 70 degrees. And then they bring in some fun algebra, right? So you're just using relationships here. I guess I'll do one of these with you, and then I'll stop talking here. So okay, so the measure of angle 2 is equal to 4x plus 7, right? The measure of angle 7 is equal to 5x minus 3. These are parallel lines. They've shown us that, cut by a transversal. The relationship here is that these are both are on the exterior and they are on other sides of the transversal, so this is an alternate exterior angles. So that means we know that they are congruent, they're equal to each other. So I'm going to set these to be equal to each other. 4x plus 7 equals 5x minus 13. Okay, and then I'm going to solve for x. So move some things around here. We get x is equal to minus 13 plus 13, we get 20. Okay. And that's all they wanted. They just wanted to solve for x. And then for b, I'll help you set it up here, and then you can finish it on your own. For part b, it says find y if the measure of angle 5 is 68. So if this is 68, and the measure of angle 3 is 3y minus 2, we know that together these guys have to equal 180, right, by our rule. Consecutive interior angles are supplementary. All right, so we can use that rule, and we can say, okay, 3y minus 2 plus 68 is equal to 180. Solve for that, and you're done. All right, guys, that's it for this time. I'll catch you guys next time. We'll work some of these in class as always.